Hello everyone, and a warm welcome to the UK's virtual stand at this year's Wind Energy Hamburg. We're here with our partners, the Energy Industries Council, the Scottish Development International colleagues, UK Export Finance and the wider UK Offshore Wind Network. This year we will be focusing on three key areas, giving you some true highlights of UK expertise. Right now we will be looking at digital technologies. These are becoming increasingly important in optimising all aspects of the life cycle of a wind farm. They enable a much better understanding by providing the tools to reduce costs, streamline operations and optimise the asset's performance. This session brings together a range of different software and digital solutions working across the life cycle. And without further ado, I will now hand you over to our speakers of today.
Hello everyone, my name is Claire House and I work for Castrol Lubricants in the UK within the Global Innovations team, and I'm really happy to be introducing the Castrol Smart Sensor to you today. Smart Sensor is an inline analytics solution which measures the health of gear oil up tower 24/7 and acts as a feed into predictive maintenance. It's been developed by Castrol and Onyx Insight, tested at BP wind farms for more than a year. The results have now given Castrol the confidence to launch this innovation solution to our wind customers. Levelized cost of energy, or LCOE, is one of the biggest challenges for wind farms, and most struggle to be in control of their operation and maintenance expenses. This is because, with an average of 225 events per turbine per year, nearly 2/3 of all of the O&M spend is from unplanned activities. The wind industry has tried to solve this issue by adopting predictive maintenance practices, and whilst these have led to some success, these individual practices also have their own limitations, as you can see from the chart on the right-hand side. In addition, current offline oil sampling can be inconsistent. It requires technicians to climb up tower, needs transportation, time for laboratories to test and report back, and typically only happens once or twice a year, meaning it's insufficient to do any real trend analysis. Castrol Smart Sensor completes this picture by providing predictive insights for the drivetrain components. Not only does it revolutionize oil analysis by bringing it inline 24/7, when it's combined with vibration monitoring, it can help remove blind spots from predictive maintenance practices, thereby making farm teams much more informed to reduce unplanned activities and downtime. What technology is used? Castrol Smart Sensor consists of two sensors and a data collector. A particle sensor detects the ferrous debris in the oil, such as wear particles from gears or bearings, and therefore helps in understanding machine health. The second sensor detects electrical measurements, temperature, and relative humidity, or water content, which provides information on the health and condition of the oil. And finally, the data collector sends the data to the cloud for analysis and decision making. The data collector also helps combine oil with vibration data to provide even richer insights into the drive time health. Castrol and Onyx Insights conducted rigorous and thorough testing of an independent testing of a range of sensors over 2 years. In the lab, we simulated a number of variables such as aging and water content and tested the sensor with different gear oils to shortlist those that perform best for the wind industry. This shortlist was then taken forward to field testing, where we installed them in 10 turbines at BP Wind. Following a year of testing in the field, these results enabled us to finalise the sensor technology for Castrol Smart Sensor. And if we look at a couple of case studies, in quite a short time, we were able to demonstrate the benefits of Castrol Smart Sensor. Here we see that when used for oil condition monitoring alone, a spike in humidity seen at points 1 and 3 on the graph, which would otherwise could have led to an oil change or at least prompted the need for another sample, the sensor was quickly identified the spike as an exception, and the trend data using inline measurement shows the humidity quickly returned to normal. Castrol Smart Sensor can help eliminate the need for premature oil change or resampling. When used together with vibration data, Castrol Smart Sensor can help pick up faults which sometimes do not get seen by vibration alone. In this case, a planet-bearing failure was identified early by increasing particle debris picked up by Castrol Smart Sensor, helping wind farms to plan their maintenance in advance and minimise unnecessary downtime. Castrol Smart Sensor provides significant value to wind farms by minimising downtime and reducing LCOE. The benefits range from monetary, improves health and safety practices, it reduces oil transportation and waste disposal costs associated with conventional used oil analysis. And furthermore, when combined with vibration, the smart sensor reduces component failures and costly downtime associated with that. The Smart Sensor offer is brought to you by Castrol and Onyx Insight. Castrol is the leading lubricant supplier to the wind industry. It is uniquely positioned to meet the requirements of the wind industry, as BP, our parent company, has established windshore farms in the US and have recently announced a strategic partnership with Equinor in offshore. Onyx Insight specialises in turbine operation and management practices and predictive analytics. This infrastructure enables us to understand the requirements of the wind industry better and provide comprehensive solutions, which are thoroughly tested at BP wind farms and continually measured through testing and using Onyx Insight. Thank you for taking your time today, and we look forward to working with you with Castrol Smart Sensor to minimise downtime and reduce levelized cost of energy for you. Please email us at industrialinsights@castrol.com or visit our wind page at castrol.com/windenergy. Thank you very much.
Waves is all about trying to build a highly accurate, localized accessibility forecast to help operational teams improve their management of offshore accessibility. RWE have partnered with us, and we've built the solution around a kind of live operational scenario. So just a little bit of background on Cognitive. The company was formed in 2018, 3 founders who'd previously worked within E.ON and then more latterly Uniper. And for probably a decade previous, they'd been the people instrumental in E.ON and Uniper's asset health monitoring and maintenance optimization solutions. So a very deep background in data science and machine learning applied to real world problems in the energy sector. What that's meant for Cognitive since we were founded is that we've been able to be an extremely innovative and hopefully quite dynamic organization. And some of the things we're proud of delivering in our short history is building out architecture for cloud-based data historians. So we're able to have an infinitely scalable operational data cloud historian that's instantly accessible across the web. We've got a really interesting and highly usable advanced pattern recognition solution for operational teams to do root cause analysis. And we've applied AI for wind performance analysis and are seeing some really excellent results in that tool. But Waves is what we're here to speak about, and that's part of our maintenance optimization offering. But it's a really interesting and sort of exciting opportunity to use machine learning techniques in a very varied and kind of imprecise environment. So what is the challenge? You have a highly complex interaction of many metocean weather variables, along with asset design decisions, vessel capabilities, crew competence, all playing into a daily decision of whether it's safe to work offshore. Overlaid on that is the challenge of how we make that decision, because forecasting is so challenging with the multivariate problem, we ask numerous people through the day to contribute to the decision. So it might be a marine coordinator in the control room in the morning, followed by a vessel skipper, followed by a series of technicians, all asked to make some sort of dynamic assessment of whether or not it's safe to transfer offshore. This inevitably results in inconsistency of decision making, and it doesn't take much delving into offshore stats to see crew transfer vessels consistently as the highest cause of incidents in offshore wind from the G+. And everybody who is involved in operating offshore wind will know the frustration on inefficiencies of having mobilized resources that you can't deploy because of poor weather conditions. So our kind of working thesis was that with data tools available to us in the modern age, there should be a way to apply some of these techniques to make a better decision around this vital aspect of offshore operations. How we went about it, I guess, for anyone involved in machine learning and big data applications, I guess the clue is in the name with big data that you need a large data set in order to apply these techniques. Fortunately, what weather forecasters seem to be excellent at is creating a large amount of data. So for some of the data feeds into this model, we've been handling, or let's say extracting from 3 petabytes worth of data, which is a number I don't even compute, but it sounds like a big number to me. We've based the model for RWE on WaveWatch 3 and Meteo France wave models, which give us a 6-day look ahead. And the model is basically built using 17 metocean variables combined into a machine learning model and then categorized with the operational history from wind farms. So your go, no-go decision then informs the model to learn which conditions, which combination of conditions it can allow or recommend access. We've demonstrated that technology could work and be a big step forward for the operational decision making, which then has led RWE to purchase the tool in a live deployment. So the next slide here shows you the live app was built for RWE. The advantage of this approach to a machine learning solution is that it puts the ownership of training the model in the hands of the site team, and it really helps with buy-in as to its outputs and understanding why it's making the decision that it is. So finally then, with new customers, we go through a build phase where we can incorporate data into our architecture. We can put in local weather forecasts if sites have particular forecasters that they find reliable. We can build in live data streams, build a model, and test and validate it against historic operational logs. We then deploy that with our customers either through our front end, or it's very easily integrated into customer existing applications, and go through this period that we're in with RWE now of refining and improving the model feedback, all with the goal that an application like this only works if you culturally embed it within an operational team. There's no point in having a fantastic solution that just sits there unused in the background. The key to any such implementation is that people trust what the model's saying, they understand it, they have access to it, and I think crucially for us is that site teams feel ownership of training this to give give them the access threshold that is right for their site.
Hello, welcome to James Fisher Asset Information Services Asset Digitalization Platform, R2S for offshore wind. At James Fisher, we have a great deal of experience with client and industry body interaction. These interactions have led us to realize some basic industry challenges that must be overcome if the offshore wind industry is to lead the way into renewable power generation for a greener world. For these needs, we recommend a one-stop shop, and here's why. One of the primary challenges we've encountered in offshore wind is simply the ability to manage the data generated by activities at various phases throughout the life cycle of the asset, be they information or inspection reports, as designed versus as-built drawings, cable routes, or other types of internally documented knowledge that seemingly have no dedicated home. These challenges arise especially in handovers between phases or between contractual parties, where assets tend to be handed over in as-is condition with little intact documentation or data. We propose to change this approach through the provision of our R2S asset digitalization system early in the asset lifecycle, ideally allowing asset operators and managers to capture information early and often in the phases leading up to commissioning. Simply aggregating that data and making it accessible to the right parties will bring millions in cost savings and efficiencies in managing the asset throughout O&M, decommissioning, and/or repowering. Having a one-stop shop for all your data and knowledge management needs will help bring the offshore wind sector out of its low digital maturity levels of simply reacting to alarms and sensors, and will allow us to get ahead of the curve using predictive models that will lead to efficiencies and increased automation capability, driving down the levelized cost of energy and increasing post-subsidy viability for the sector. At James Fisher AIS, we've chosen to address these challenges with digital twin solutions. Using our R2S platform, which allows the incorporation of any type of data or data streams, as well as seamless integration with third-party offerings commonly used throughout the industry, such as SAP and Maximo. As a service, we also offer a wide range of data science solutions that can be tailored directly to your needs, whether it be high-voltage cable monitoring or accelerometer data from sensors in your towers or turbines. Everything we do is designed to bring cost savings and enhance safety to your operations by saving you time and money in planning and work pack prioritization while reducing unnecessary offshore trips and unplanned downtime. You can now lead the way forward from a sustainable one-stop digital platform that allows you to bring more of your company's data solutions in-house, where you really need your best decision support tools.
Thanks, Bill. I'm now going to give a very brief demonstration of the R2S platform, showing how these industry pain points can be alleviated. R2S gives any operator of an asset the ability to collate, view, integrate, and collaborate using the data that they already have available. R2S brings powerful digital twin capability to teams tasked with managing assets and project life cycles, presenting any site data in real-world context to plan better and make decisions faster. We realise the need to be data agnostic, so we take in information from any source. As you can see here on the right-hand side, the amount of data types we have within this demonstration is vast, and R2S is not limited to just these. These can include anything from anomaly reports, tag data, laser scans, and static imagery. We also realise the upheaval of changing systems, so instead integrate them, providing a contextualised view of key information. I will show you the ability to pull through live information in this next example. R2S layers key bits of information together to make it really easy to use. As I click on any of these hotspots, it brings up a further layer of data. Here we can see the side elevation of a turbine. If I'm to click on any of these hotspots, it will bring me to the related plan. If we go into the nacelle, you can see that there are multiple hotspots placed already. The red hotspots allow you a full 360-degree view of that location. If we click on one, we can look about the area. We have integrated live information, so as I hover over any tag, it pulls through that. Here we have gas flow and pressure. R2S integrations also have the ability to visually change a hotspot. On this example, you can see a small green tick in the corner of the hotspot. When you hover over it, it shows that it is a pass. Similar hotspots can be seen in this area of the nacelle. Some with an amber exclamation mark, others with a red cross. This simple way of visualizing passes and fails allows a user to quickly see if there has been any changes within an asset. R2S is the window to all your data. This allows your team, supply chain, or subject matter experts to make data-driven decisions remotely, limiting the need for unplanned visits to site or taking up key space on the vessel. This example shows how inspection reports can be linked to the imagery. Here we have the blade. Attached, we have images showing possible damage. Attached to this, we can add the inspection report, so it's really quick and easy to find for any user. Using R2S for digital handover from the beginning of your project allows this type of data to build on itself over time, meaning that analysis can be used to trend for failure prediction and prioritise planning interventions accordingly. As you can see here, this can be used on any element of the wind farm, from substations to the turbines to the cables themselves. Any area that you have data, we can pull it into R2S. R2S has been proven for over 10 years in multiple industries, including oil and gas and forensics, meaning we have tried and tested use cases, experience, and the software setup is flexible to suit the security needs and varying IT capabilities. This includes a web viewer and also the ability to restrict users to what they can see and what they can do within the software. If you'd like to contact us, we can be reached at the following emails and numbers. And to see our case study with Vattenfall, please click the link below, which can be accessed from our James Fisher Asset Information Services site at www.jf-ais.com.
Hello, JBA is a specialist flood, weather and climate risk management company. We manage these risks for a wide range of clients across a wide range of sectors, from governments and NGOs to insurers and through to the offshore renewable energy sector. Our services are focused on three main skill sets: advanced analytics and computer modeling, software development, and engineering design. We are a British-born company, and this is where we are headquartered, but we have over 700 staff operating from 7 countries, from California to Brisbane. One of our emerging USPs is logistics and metocean risk management for the offshore energy sector, including wind, wave, and tidal. The marine operations in this sector are complex and costly and heavily dependent on weather. There is much to be gained from using advanced analytics and modeling to optimize construction and O&M strategies and to help contribute to lowering the levelized cost of offshore energy. So this is why we invented Four Coast Marine. our award-winning logistics and metocean risk management system. Forecoast Marine includes a suite of advanced tools to support the management of metocean and logistics risks across the lifetime of a marine energy project, from early concept design and optioneering to the design of detailed construction and O&M strategies, and through to the management of daily operations. Forecoast includes two key components: the simulator, which is used to design and test O&M strategies and construction strategies using virtual world technology, and the mission planner, which uses weather forecasting and AI techniques to support daily operational planning. First, the simulator. See the simulator here. In essence, the simulator simulates, in this instance, the construction of a wind farm within a computer model, using historical metocean data and detailed information on the operations required to construct the wind farm and how they are affected by metocean and logistics constraints. By computing thousands of simulations, the simulator can be used to predict how long the construction will take, how much it will cost, and the dates of key milestones. But even more importantly, the model can be used as a powerful optioneering tool. The model can be used to simulate how different construction strategies will affect CapEx and construction programs, considering options like foundation and turbine type, vessel types and numbers of vessels, operating port, and seasonal working strategies. By doing this, the model can be used to optimize a construction strategy that best suits local circumstances and provides a high level of due diligence to demonstrate to investors and insurers. The simulator can also be used to simulate O&M and to optimize O&M strategies. The O&M model includes the turbines, and if the wind is blowing in the model, the turbines spin and generate revenue, which you can see in the revenue counter here. The model also includes both regular maintenance activities and failures in turbines. When maintenance or failure repairs are required, the vessels in the model try to do the repair, depending on metocean and logistics constraints. Of course, the quicker they can get the repair done, the more revenue can be generated. Like the construction model, the value in the model is testing how different O&M strategies will affect performance. For instance, is the CTV strategy most effective, or would an SOV strategy be better? Or would some combination of CTVs, SOVs, and helicopters best suit the project circumstances? The model can be used to determine this and provide robust estimates in terms of OpEx. So that's the simulator, which is used to design and optimize construction and O&M strategies before you get into the water. The mission planner, on the other hand, is used to manage metocean and logistics risks on a day-to-day basis using weather forecasting, information on planned operations, and advanced AI algorithms. The system, which is entirely web-based, includes tools to anticipate weather impacts into time and sequence operations to reduce costs and emissions. The coolest part of the mission planner is our AI tool. This tool is used to manage the situations like this. We have a very large wind farm that is far from shore. It's serviced by 3 CTVs. It has 40 technicians, each with different skill sets. There is a long list of routine maintenance that we need to get done over the coming days. We have a 5-day weather forecast. This tells us about how much energy we might be able to produce, and also about how easy it's going to be to access the turbines. So the question is, what should we do? Where should we go? What sequence of operations and technician movements will minimize costs and maximize revenue, considering things like turbine downtime, vessel and technician availability and costs, fuel and emissions, and weather? The number of potential permutations for what we could do is immense. Solving this with the human brain or even a spreadsheet-based approach is simply impossible. Forecoast AI does this using advanced AI and routing algorithms. The key output from the system is a detailed manifest of drop-off and pickup times and optimized routes around the wind farm. The technology can be used to support O&M daily planning as well as AUB logistics. we have been working with another UK firm, Modus, to implement the system to support daily logistics planning for AUV operations. You can see an output from the model here, which demonstrates how to best sequence movements of the AUV around the wind farm, considering battery life, currents, weather, and other logistical constraints. So this is a little bit about JBA and about our groundbreaking 4Coast Marine software. We hope this was of interest to you, and we would love to hear from you. My name is Mark Lawless, and my email address is shown here. Please get in contact with me. I'd love to speak with you. Thank you.
Welcome to this presentation by Onyx Insight, where we're focusing on digital technology and software analysis for offshore wind and Onyx Insight's AI Hub, bringing the full weight of engineering expertise in a new disruptive AI platform. Value is being lost by dispersed data, and there's a number of reasons for this. Managing multiple software is complicated. Analytics requires expertise in respective data channels, and different analytics teams are often considered in isolation. Wind farms are gathering lots of data, but are rarely putting it to good use, with data often sitting on a server somewhere, not generating value for a company. There are several key reasons for this. The storage, retrieval, and manipulation of this data is often complicated and tends to require specialist software to deal with each data source independently, for example SCADA, vibration, maintenance, etc. This software is rarely designed to integrate with other software, so you need lots of screens and programs running to even start getting an idea and overview of your data and what it means. The actual analysis of this data is often more complex and needs experts in their respective fields to drive results and therefore value. These experts are rare though, and often expensive. Furthermore, they're rarely experts in multiple fields, so you'll need multiple teams of experts to drive value from your data. These teams of experts rarely talk to each other. At best, you have each team coming to a site manager independently and saying that their problem is the most immediate, which is very difficult then to get an overview of the health of your farm. To minimize O&M costs in its simplest form, you want to be doing one of two things: detecting faults before they cause lost energy and ensuring that every megawatt hour counts. It's therefore worth knowing about where the typical O&M costs are for a fleet of wind farms in 2020. The modern day wind farm challenge, where every megawatt hour counts. This table shows the typical O&M costs for a wind fleet in 2020 as a fraction of the lost energy root causes. The most striking thing is the diversity of causes, where no component contributes more than about 20% to the total lost energy. Lost energy, and therefore cost, is spread amongst different components. You can no longer focus on any single component and expect to make significant savings. The table 10 years ago would have shown far higher lost energy in gearbox and electrical faults, which at the time dominated over other fault types. Improvements in these components over years have meant that we now have to turn to a more holistic approach. Also, the old approach was focused on avoiding catastrophic failures, where it's now much more focused on maximizing savings and predicting faults as far ahead as possible in order to bunch work orders together and save on costs to ensure downtime is limited to the non-windy off-season. This all points towards a new trend in O&M digitization. Focusing on drivetrain and avoiding catastrophes is no longer enough. O&M digitization encompasses full turbine analytics, lost energy minimization, machine learning and AI, all supported by engineering expertise and domain knowledge. O&M digitization is the way the market is heading. Machine learning is a term that's heard more and more nowadays, so let's define that. Machine learning is a suite of tools and algorithms that enables computers to perform pattern recognition. Machine learning will detect patterns in your data, but only domain knowledge and engineering expertise can tell you what those patterns mean. and it's time to put your data to its best use. Introducing AI Hub by Onyx Insight. AI Hub provides multi-channel data and advanced analytics in one place. The software accepts and integrates a variety of different datasets, so you don't have to worry about how to integrate them. Powered by pattern-detecting machine learning tools in the back end, problems are automatically identified and detected. The context for the AI and ML models is provided by our in-house team of consultants and engineers. Information is provided on gear failures, blade imbalance, bearing failures, oil condition, and lost energy, with instant access to our consultants if more help or advice is needed. The software has been designed to be open and easy to put data into, but also easy to take your results and data out. It uses our state-of-the-art analysis and integrates seamlessly into your own systems or front-end platforms. AI Hub consolidates both Onyx and third-party data streams. Input into AI Hub includes inspection data, condition monitoring data such as vibration, SCADA and oil, AI and machine learning such as advanced SCADA analytics, and engineering support, so consultancy services from real engineers to support decision making. Case Study 1, Pitch Accumulator Fault, in Europe, onshore. This case study focuses on a pitch accumulator fault. The pitch accumulator is a safety critical component of the pitch system. If there's a fault with it, the turbine shuts down and will not start up again until the fault is fixed. This was causing significant downtime on an offshore farm of one of our clients. The grey lines in the background show the raw signal, with no obvious indication of a fault anywhere in the raw signals. The black line shows our model's output. This particular model is a type of neural network called an autoencoder. It considers not only the absolute values of the raw tags, but also their correlations with one another, and uses this information to detect if anything is changing in a concerning way. This is what the black line shows. Around July of 2019, the autoencoder detects serious changes in the behaviors of the system and alerts the farm 6 to 8 months before failure. Repair takes place in November 2019, and the autoencoder registers that system is behaving as expected once again. The wind farm has had no previous way of detecting these faults, and they were causing significant downtime. Now, all maintenance is predictive, and replacements can be scheduled with plenty of lead time. Case Study 2, Temperature Fault, Europe, offshore. This case study focuses on temperature issues. The temperature versus vibration correlation identifies an event when temperature gradients are affecting the component loading. Onyx created a bespoke machine learning model to guide maintenance action and control maintenance quality. In summary, the scope of predictive maintenance is expanding to include full turbine monitoring and lost energy reduction. This allows operators to move away from reactive maintenance and avoids downtime due to shutdown. It also means less turbine climbs. AI machine learning is a useful tool, but care is needed. We'll finish up with a quick summary of who we are. Onyx is a global leader in predictive maintenance software and services. We provide unbiased predictive analytics underpinned by engineering expertise. We have an engineering heritage of rotating machinery design, monitoring and lubrication. We have a truly global reach with offices in the UK, USA, South Korea, India and Australia. Onyx Insight has over 10 years expertise in big data analytics. Our track record includes over 6,000 wind turbine monitoring services, over 2,000 gearbox teardowns and inspections, over 60 gigawatts of reliability data of assets worldwide, and over 10 patents on our unique technology. If you'd like to get in touch with us, please contact us at any of our offices. Thanks for listening.
Hello everyone, my name is Gabby Amiel. I'm the CEO of Senon. We are a tech business working at the cutting edge of operations and maintenance for offshore wind. So very briefly, Senon's mission is to deploy software systems to improve safety, create efficiencies and deliver value for renewable energy operators. Senon currently supports several major clients, both offshore and onshore, including London Array, the world's, or until recently was the world's largest offshore wind farm. But what is the challenge that we're facing with offshore O&M? Well, O&M is absolutely critical to the productivity and to preserving asset integrity offshore. It's a huge cost to deploy technicians and just the personnel, but also the cost of the vessels to get them out there. But actually the biggest cost overall is lost production when turbines sit idle, so minimising downtime is absolutely key. The logistics of O&M management for offshore wind are absolutely horrendous. If you can imagine having 100, maybe 150 people working on site at any one time, miles offshore in extreme conditions, sometimes on a 24/7 shift, and moving around the site to multiple locations. All this activity has to be governed by detailed safety and competency procedures. Controlling and improving this activity is critical, but when it's done through disparate and generic software systems, it can be a massive hindrance to the site operations. So this is where Senon comes in. Senon is an end-to-end operations system for offshore wind. We plan and deliver works, we manage compliance and hazards, and provide centralized, reliable information to the whole team. Our offshore system has been in live deployment for well over 3 years, and it's used by everyone, from the technicians on the ground right up to the CEO of the operation. We have managed to increase team efficiency by 30% or more, and we've also shown major improvements in safety and productivity over that time as well. Senon has been purpose-built for the industry to solve its particular challenges. Myself and my co-founder Paul Grimshaw have been working as in the asset management of renewables for over 30 years combined, and we have a growing team of software developers and engineering capability. I'll walk you through a quick overview of the modules that sit within our offshore system. We optimise the deployment of resources, whether that's manpower or vessels, to ensure that the most critical work is done as the highest priority. Secondly, we automate the health and safety process, providing safety checks and digital safe systems of work, so we can speed things up and improve safety outcomes at the same time. Finally, we provide marine control and coordination, tracking vessels and personnel around site. We also bring in SCADA data to enhance the understanding of the engineers of what's going on site. We give full site conditions, live data and forecast data, and we have a playback history mode so that you can interrogate exactly what's happened days or weeks before. All our products and applications are built in our own cutting-edge technology framework, which essentially is designed for data integration and customized applications and modules. With Senon, our clients have a single view of all their relevant information. With such a clear overview and efficient working processes, our clients are able to manage their wind farms efficiently and effectively and safely. And our clients tell us that this is crucial to their operating success and their business strategy. Finally, I've got a nice quote here from one of our clients at London Array. If anybody's interested to read more about our work, there's case studies available on our website, so don't hesitate to get in touch, and we'd be happy to share it. We'd also be pleased to give you a full demonstration of the Senon system in action. that concludes our presentation. I'd like to thank you for listening and welcome any questions. Please don't hesitate to get in touch. Thank you very much.
Hello, my name is Alan Mortimer, Director for Innovation at Wood Renewables. The product and service I'd like to talk about is gallium scanning LiDAR. But first of all, briefly, an introduction to the company. We are a large global engineering and project services company, 45,000 employees, working in 60 countries with over 400 offices and annual revenues of $10 billion, covering the whole project life cycle and working in all of the major energy and infrastructure sectors. So that's oil and gas, clean energy, mining and minerals, power and utilities, and process and chemicals. One sector we are heavily involved in is offshore wind and the various activities mentioned in this slide. The ones in light blue relate to floating wind, an exciting new growth area. In total, we've worked on over 100 offshore wind projects. It's 50 gigawatts worldwide. That's over 70% of Europe's offshore wind projects and 3/4 of Asia Pacific's. Some world firsts to mention, including world first scanning LiDAR on a floating wind turbine. That's at Highwind, Scotland, and there the challenge was to have motion compensation to stabilise the LiDAR system. Also providing equipment, so providing equipment for the platform electrification work at the world's first floating wind platform electrification project at Tampen for Equinor. Also working on many fixed offshore projects, including some of the largest in the world, such as Hornsea 1. So focusing on LiDAR then, and how does scanning LiDAR work? Well, it sends out a laser beam that reflects off particles in the air. These reflected beams are picked up by the LiDAR unit, and the Doppler shift reflects the radial velocity of the particles, and that builds up a picture over a hemisphere of wind, and that allows a full picture to be built up, much more detail than can be achieved through anemometers, for example. So we're great advocates of LiDAR. The volume and quality of information it gives really transforms our understanding of what's going on. And here, for example, is a vertical scan of wind approaching a turbine and then behind it, and in both cases showing how the turbine is impacting on the wind to allow us to fine-tune our models and more accurately predict what's going on. Here's an offshore LiDAR application, and here's an onshore one. And so we have exclusive rights to gallium LiDAR. It's been deployed in the wind sector since 2008. It's over 1 million operational hours and 100,000 hours of performance verification. And also, I should say, many years of operation in the offshore environment. These are the countries where LiDAR has been deployed. And these are some of our customers. And it has been independently verified by each of these organisations. So now, based on 12 years of experience and feedback from customers, we've designed and developed a new scanning LiDAR device called New Gallium. Here it goes, with a number of benefits. So the range is increased to 6 kilometres. In fact, we've achieved 7 kilometres in our trials. Faster scan speed. It's lighter weight, 70 kilograms, much lighter than the competition. So it can be deployed on the nacelle, on the ground if it's an onshore wind farm, or on the transition piece if it's offshore. These are the technical characteristics. We have detailed data sheets for anyone who requests it. Potential applications include power performance testing, which now can be done to meet the IEC standards. Power performance testing can be done for multiple turbines from a single transition piece LiDAR offshore, and that therefore being a very cost-effective and quick way to gauge performance accurately. Studying compounded wakes, in this case a vertical scan or a horizontal scan, can be used to establish exactly what's going on in a range of atmospheric conditions. We've done that. It's allowed us to fine-tune our computer models, make them more accurate, and so we can predict performance more accurately, but we can also better optimize layouts at the design stage. Other applications, assessing complex shear is a particularly nasty characteristic of wind flow offshore under certain conditions, which is really tough on the turbines, and we're able to measure and project that using LiDAR. We also have an opportunity with gust tracking. So we've established with scanning LiDAR, we can track gust fronts coming into the wind farm from several kilometres upwind, giving advance warning to the turbines, allowing them to adapt their control systems to better smooth loadings and extend the life of the turbines. Blockage effect and compression zone. Now this is whether it's for individual turbines or even the whole wind farm. They do have an effect on the wind flow as it approaches and around the sides. And on approach, for example, we have already shown with LiDAR that 2.5 diameters upwind does not get you entirely away from the blockage effect of the turbine. Therefore, to accurately measure performance, you need to be looking further ahead with a longer range LiDAR. So in summary then, new Gallium LiDAR has been developed to meet industry needs. It's got longer range, it's faster, it's lighter, and it's cheaper. Applications include post-construction energy yield validation, turbine performance tests, and that can be for multiple turbines to IEC standards, compounded weight characterization to allow more efficient wind farm layout design, complex wind shear measurement, gust tracking and control optimization to extend turbine life, and shore-to-site resource characterization. I haven't mentioned that, but for nearer shore sites, our long-range LiDAR can be used to assess wind from the shore. So each of the above or combinations may be used to further optimize wind farm performance and lifetime. So thank you very much. That completes my pitch, and there are my contact details if you would like to follow up. Thank you.
I hope you found this session useful. It's just one of the 3 sessions, so stay with us for the highlights on autonomous technologies and floating wind. On this site, you can download the UK Pavilion brochure at Wind Energy Hamburg 2020, where our contact details are available.